It was a historical day back in 2017, when scientists spotted the region immediately surrounding a supermassive black hole using a ground-based telescope. Now, with the James Webb Space Telescope in action, that day in 2017 will be seen just like any other day in history, because this space station telescope is on a mission to make some of the most terrifying and unexpected discoveries in the history of mankind, from witnessing the birth of the first stars in the universe to the search for extraterrestrial life. The James Webb Telescope is going to change how we view our universe. Early images are already here, and the results will shock you. So, keep watching this video if you want to know more about the shocking discoveries this telescope has made. Before we begin to talk about these discoveries and how they will affect us, we would like you guys to subscribe to the channel, like this video, and hit the notification bell icon so you do not miss out on amazing space content. You must be thinking what even James Webb Space Telescope is, so before we talk about the unexpected discoveries it has made, first, we would like to tell you guys a little bit about the telescope itself. The James Webb Space Telescope is an infrared observatory orbiting the Sun about 1 million miles from Earth. It is NASA's largest and most powerful space project built in collaboration with European and Canadian space agencies. Decades in development and costing almost $10 billion. The Webb was launched to space last year in December. The whole science world was on the verge of their seats as the telescope was shot off into space. Now that you guys know what James Webb Space Telescope is and what are its functions, let us begin to list down some of the most unexpected and shocking discoveries it is going to make. The primary mission of the James Webb Telescope is to witness the birth of the first stars and galaxies in the early universe. As the light from these very vague galaxies travels across the vast stretch of space, and it gets stretched by the overall expansion of the universe in a process we call cosmological redshift. This light will be measured by the James Webb Space Telescope to determine the age of the universe. If you are somewhat interested in astrophysics, then there is no chance you would not know what a black hole is. But for those of you guys out there who do not have any idea about black holes and randomly stumbled upon this video, a black hole is a place in space where gravity pulls so much that even light cannot get out of it. The pull of gravity is so strong because matter has been squeezed into a tiny space. As light cannot get out, black holes are virtually invisible. However, space telescopes with special tools can help locate black holes. These special telescopes act on the principle of how stars that are very close to black holes act differently than other stars. If you have seen the first aligned image from the James Webb Space Telescope, then you would notice a lot of different things happening in that image. The first image shows a huge object with many bright spikes radiating from it. The huge object in the center is the star, 2MASSJ1755442 plus 6551277. We know the name's kind of a stretch, but that's what you get when you have billions of stars roaming around in the space. The star is used as a calibration object for the telescope. It is just a normal faint star in our galaxy about 2,000 light-years away from us. Now, coming towards the spikes. These huge spikes are actually not radiating from the star. These spikes are due to the courtesy of the hexagonal mirror of the telescope. All this may seem exciting, but the real stuff is happening in the background of the image. If you focus on the background, you could see that the background objects contain many stars and galaxies. Webb happens to be so powerful that its optical sensitivity reveals not only the star in focus, but also shows distant galaxies and other stars as faint objects in the background. Most of the shining dots are stars and spirals ones are galaxies. If you look closely, you can see a black object surrounded by light-year star. This black object closely resembles a black hole, based on the theoretical appearance in images from 2017, when scientists spotted the region immediately surrounding a black hole. We will have to wait a little bit for more images to come so the experts can confirm this discovery. When you are looking up in the sky at night, you see thousands of stars, but have you ever wondered which one is the nearest to us? Well, based off the images captured by NASA's Hubble Telescope, the closest star to our Sun is Alpha Centauri system, just over 4 light-years away. Now, the special thing about this star system is that it might be a binary star system. Now, you might wonder what's a binary star system. Well, a binary star system is a system of 2 stars that are gravitationally bound to and in orbit around each other. Binary stars are seen as a single object to the naked eye, but are often resolved as separate stars using a telescope in which they are called visual binaries. Aside from its main objective of observing the birth of the first stars and galaxies, the James Webb Telescope will also be the NASA Great Observatory and assist other telescopes in their mission, such as the iconic Hubble Space Telescope, Spitzer Space Telescope, and the Compton Gamma Ray Observatory, to name a few. In addition, the James Webb Space Telescope will provide an even greater step forward, providing rest-free visible light images of even more distant galaxies obscured by dust, such as the centers of galaxies where supermassive black holes lurk, or the regions of intense star formation in our galaxy and others. Webb will also be sensitive to very cold objects, including low-mass stars and planets orbiting other stars within the Milky Way. Another big improvement on the previous telescopes is that the Webb will be well equipped for spectroscopy, dissecting light into its component wavelengths. This will let us measure the cosmic redshift of galaxies more precisely and figure out what elements they are made of, which can be directly compared with images of nearby galaxies at visible light wavelengths. When the first plans for James Webb Telescope were on the table more than 20 years ago, no planets were known other than those in our own solar system. Since then, astronomers have discovered thousands of planets orbiting other stars in our galaxy, termed exoplanets. A significant portion of Webb's observing program will be devoted to studying the atmosphere of these exoplanets. Currently, two techniques are available. One takes advantage of the fact that planets can pass in front of their parent star called a transit, which creates a dip in the light we see from it. By analyzing the light before and during a transit, we can see the planet's atmosphere to unveil what molecules it consists of. Astronomers all over the world await with anticipation for more data to be collected from the telescope in the next few months. As for myself, perhaps the most exciting aspect to look forward to is the completely unknown. And with that, we're done, and thank you for watching. If you would like to receive the best updates about space, make sure you click the subscribe and bell icon. See you next time.